All right, can y'all hear me okay? I think I have pressed the go live button now. Let me know in the chat if you can hear me okay. Everybody drop me a 7 in the chat if you can hear me okay. Awesome. Very cool. Well, I'm going to give us maybe just 2 more minutes here for people to roll in, then we'll get started. All right, so let's go ahead and get started here. So welcome to the Flash Loan Masterclass. So I'm super excited to show you how to start coding with Flash loans. With this skill, you can unlock a superpower that's gonna let you borrow millions of dollars of cryptocurrency, basically for free so that you can use it in DeFi trading and so much more. All right, so this is an absolute superpower because there's nothing really quite like this anywhere else except with blockchain. And, as a developer, you have this ability to unlock this superpower and use it for lots of different things. And I'm super excited to show you how to do that in tonight's presentation. So let's go ahead and get started. So before I do that, let's just cover a couple, really quick bits of housekeeping to show you how much you can get out of the class tonight. But I guess let's talk first about like exactly what we're going to cover. So first, we're going to talk about what you need to do in order to start understanding Flash loans and how you can use them in your own applications. Okay. So we're going to cover the basics. All right. We'll start off with the basics, but then we'll quickly move on to the more advanced topics. Right. We'll just assume that not everybody here knows everything. All right. So we'll start with the basics, like what are Flash loans? How exactly do they work? How can you use them? All right. We're going to look at a basic Flash loan implementation with code so that you can, just take smart contracts, start performing Flash loans, and then show like how you would use that, to build an application, show you where you can plug in different parts, change, aspects of the Flash loan. We'll start, kind of simple there. And then we'll quickly move to something a little more complicated, where I'm going to show you a complete coding solution. It's actually a passive income app that you could literally just turn on that would earn money with Flash loans now. Okay. So, and then that'll give you some ideas on how you can create your own applications. Quick piece of housekeeping. So some house rules for the presentation tonight. Number one is if you have anything to talk about, keep the chat inside the live stream chat here. Okay. So if you're part of the blockchain mastery program, don't try to keep the messages, inside the blockchain mastery chat room. Try to keep them in the YouTube chat room. I'm only gonna be able to look at, one chat room tonight. All right. I'm just gonna keep my focus on the YouTube chat. And if you're a part of the blockchain, if you're not part of the blockchain mastery program, you just joined the one-time class tonight, and you want to unlock all the benefits of that vibrant community, like weekly videos, all the past master classes we've done inside of your community chat, then you can definitely reach out to Gregory at dappuniversity.com and we can switch you over to that. Okay. So we will be taking questions through the presentation tonight. Let's try to save a majority of our questions toward the end. We'll have an extended time of Q&A, and that'll help me not get so distracted from like watching the YouTube chat. I'll try to watch things periodically, but it's hard to like present and focus on everything and also watch the questions that are flying across the screen there. So let's try to save a majority of questions till the end. And then we are going to look at some codes tonight, but the best way to get the most out of this class is to not try to code everything out with me while I'm doing it. You can try, but most people are going to get the most out of it by just watching the presentation, getting the overview of how the stuff works, and then taking advantage of that replay. So if you join the one-time class tonight, you're going to get a replay link. If you are part of the Blockchain Mastery program, of course, this will be uploaded to the video vault inside of there, and you'll have full access to that as well. Okay. So now we are going to show how all the code works tonight. We're not going to have time to code out every single example step by step. Okay, so we're not intended to be exactly step by step on everything. So if you want to learn how to code step by step, start to finish, then you can definitely check out the Blockchain Bootcamp. That's exactly what that's for. There's a discounted link below tonight for being part of this presentation. Okay. And the last bit of housekeeping is the income and risk disclaimer. So everything we're going to do tonight, I'm going to show you step by step how to do this inside of a sandbox environment so that there's zero risk involved. Okay. So for that reason, if you do it in this sandbox environment tonight, there's no like guarantee that you're going to make profit because we're just going to use test money. All right. And you can't, but that's a good thing because it means when you're trying things out, when you're practicing Flash loans, you want to do that. You want to do it in a sandbox environment where you're not having any risk of losing any cryptocurrency. And because there are significant risks associated with, DeFi and leverage and all that type of stuff, if you, take the coding examples tonight and then take them out of the sandbox environment onto a live blockchain, then there will be risks associated with that, which I will call out clearly in the presentation. All right, so make sure all that's clear. With all that said, let's go ahead and jump in. I think you can get a ton out of this class tonight. So let's start with basics. Like what is a flash loan? All right. Again, we're going to kind of just assume that we're going to start off with helping people who, may not know some of the basics. I'm not going to assume everybody here is an expert in everything. We'll quickly move beyond the beginner topics to, more advanced portions of the presentation. But basically, flash loans are, cutting edge technique that lets you borrow millions of dollars in cryptocurrency basically for free. Okay. With zero money down so that you can use it for trading, DeFi, so much more. We're going to talk about plenty of examples tonight. And the best part about this is when you're borrowing this money, you don't have to put money down, and there's no risk that you can actually lose the money that you're borrowing. So, for example, if you borrowed $1 million in cryptocurrency, there's no possible way with the blockchain that you could somehow lose that $1 million. Okay. And that's insane. So the catch here is that whenever you borrow this money, you have to pay it back all in the same transaction. Okay. So that might be kind of confusing. So what does that mean? Well, let's take a look here. So let me just pull this example of my screen. Hopefully you can see this better. So, blockchains, what they are, basically blockchains are just worldwide computers that just process transactions and settle records across, they settle all these transactions across multiple accounts across the entire open public ledger. So basically a blockchain is just this big worldwide shared public database of a bunch of different cryptocurrency transactions and also different transactions that are related to smart contracts or programs that run on the blockchain. So, all those transactions are grouped together into bundles of records, all right, called blocks, which are chained together to make it the blockchain. And all those transactions have instructions inside of them, okay? So there are very simple transactions, and there are complex transactions. So here's an example of a simple transaction pulled up on my screen here. So basically, let's just say that I wanted to send, Ether or some sort of cryptocurrency from my wallet to yours, okay? That's a simple transaction. It just has one instruction inside of it, one step. It just says, take cryptocurrency out of my wallet and put it in your wallet. Okay, that's a simple transaction, just one step. All right. But blockchains also support complex transactions. This is a simple transaction. It also supports complex transactions, and that's where flash loans can come into play. Okay, you could have a multi-step transaction that looks something like this. So step one might be borrow some money, right, with a flash loan. You might be able to borrow $1 million or more. Step two might be do something with that money. Okay, maybe you want to trade it on 2 exchanges. Maybe you want to use it in DeFi. Step three will be pay that money back. Okay. And then step four will be keep the profit. All right. That's multiple steps. That's a complex transaction with multiple steps as opposed to a simple transaction with just one step. So, when I say, you can borrow millions of dollars of cryptocurrency for free, to do whatever you want to, as long as you pay it back in the same transaction. That's what I mean. You're performing a single transaction with multiple steps. Borrow money, do something with it, pay back, keep the profit. And this transaction will only be successful if, the steps here all work. If any of these steps fails, then the transaction fails. And for that reason, the loan won't actually take place. The loan only takes place if all these 4 steps work. And that's how, you're not on the hook for losing any money. Now, simultaneously, you won't make any money off of a flash loan unless your transaction goes through. And, you would lose out on gas fees for attempting this transaction. So there's a little bit of risk involved. But the big benefit is that, you have the ability to do this as long as you pay it back in the same transaction. That's what it means to do that. And another point I'll make here is that, on a blockchain like Ethereum, for example, all the transactions, whenever you're borrowing money, you're sort of the star of the show for that particular transaction. Like nobody else is able to execute a transaction while you have the money. So you have full access to the entire blockchain because they're processed, one by one in this way. And that's what makes those flash loans possible with these multi-step transactions. Okay. So we got people asking where's the code. The code is going to be in the description below this presentation. Wherever you're watching it, if you're watching the live stream, it's in the video description on YouTube. If you're watching on an embedded page or something, just click through to the YouTube link. It's an unlisted link, so only people with the link who sign up for the class or in the Masterclass program, have access to this. It's not like it's a public video, YouTube video. Same if you're watching the replay. So that's the basics of what that means with simple and complex transactions. So how do you create complex transactions? All right. If you have a simple transaction, like I showed you before about just sending, cryptocurrency from one account to another, you can just do that with a blockchain wallet. Like if you have a MetaMask wallet or some other, blockchain wallet, you can just send cryptocurrency by clicking a button. All right. But these complex transactions require something more. And that's where you have a huge edge as a developer because you essentially create these complex transactions by coding them. Okay. That's what smart contracts are for. So you can create a smart contract that has functions inside of it. All right. And each of those functions are just like, groupings of instructions that can be run over and over again. And each line that function can be an instruction inside the transaction. So if you're a developer, you might write a line of code that says borrow money. You might write the second line that says do something with the money. You might write a line that says step 3, pay the money back. And then, step number 4, transfer the profit back to your wallet. That's how being a developer unlocks this huge potential, is because you can do anything you want to inside of a transaction. Okay. So that's what it looks like to have, all these different things. Let's clarify each properties of flash loans. Again, you can borrow huge amounts of money, millions of dollars or more at a time, although you don't always need to borrow $1 million. As we'll see in this presentation, sometimes you just need to borrow smaller amounts. You can take out loans with no collateral, which means zero money down. Okay, you can do it basically for free. Most flash loan providers do charge a fee of some kind to take out the loan, so you have to factor that into your profitability. But as we'll see in tonight's presentation, some of the fees are basically zero. Like they're so small, they're not even worth accounting for in terms of profits. And some providers actually have completely free flash loans. I see those floating around from time to time. But yeah, the other big thing is that there's zero risk that you can lose the money that you're borrowing, but there are potential risks to your own funds, depending on what you do with the flash loans, which we'll talk about in tonight's presentation. Okay. So let's talk about where the money comes from when you're doing a flash loan. All right, where does it come from? You're borrowing this money. It's out there somewhere. Where is it? Well, many flash loans come from other DeFi applications. All right. In fact, they're often they're usually secondary functions of DeFi applications. So let's look at these examples and see how this works. So a lot of DeFi apps, have some sort of financial. Oops, my notes went off the screen there. So, a lot of DeFi applications, they need money in order to operate. So, for example, if you're going to go use an application like Uniswap, all right, Uniswap is a cryptocurrency exchange where you just, swap tokens. You tell it what cryptocurrency you have, you tell it what cryptocurrency you want to receive. It's like a vending machine, all right? You give it one cryptocurrency, let's say Ether, for example, and you get back a second cryptocurrency like, DAI tokens. So when you do that, where does the money come from when you're swapping those tokens, right? There's nobody on the other side of the screen giving you those back. Well, they're inside these things called liquidity pools. So all these DeFi apps need money to run, and the money for those applications often sits in these smart contracts called liquidity pools. So basically, you have a DeFi app with these different pools inside of it that have different amounts of money. Sometimes it's different cryptocurrencies inside the same pool, but I just made this simple example here. And you have, decentralized users on the back end who are providing money to these pools to get a passive income reward for doing that, right? So they deposit money in the liquidity pool, the DeFi app gets money to run, and then the users get this passive income reward. They're the liquidity providers for doing that, okay? And flash loans are typically made possible by being a secondary function on these liquidity pools. The apps say, hey, we got this money sitting here. We can make use of it, for one transaction. So let's let people take out flash loans and we can charge a small fee for that and they can make our protocol money. So, the flash loan provider may not be a flash loan app. It may be a different DeFi app, but then they provide the secondary functionality of flash loans that let people do it. Let's look at how that would work if you were to hook your own application to a flash loan. So basically, you have a DeFi app, you'd have a liquidity pool, and then you'd have your own custom smart contract that you write that talks to the liquidity pool in this DeFi app. It takes out a flash loan to your contract and does something with it, exchange, arbitrage, yield farming, liquidation, whatever you want to do. You take out the flash loan, you do something with it with your own custom code, you pay that flash loan back to this liquidity pool. So what can you do with flash loans? All right. What like if you've got them, what are they for, really? I mean, cool. You can borrow this money. You can borrow millions of dollars of cryptocurrency. What are the actual applications of that? Well, there's lots. We're going to show you tonight how to use it for yield farming to actually create an app that just continuously generates passive income. But let's look at some other examples. So one really popular example is arbitrage. So basically, arbitrage is exploiting price differences on cryptocurrency exchanges. I say exploit. It's not a bad word with like bad connotations. It just means to, seize an opportunity. So basically, let's say a token trades for $100 on one exchange and it sells for $101 on a different exchange. You could theoretically buy the cryptocurrency. You could buy a token on this exchange and sell on this one for a $1 profit. All right. Now, what if you could do that 1,000 times, or with 1,000, of those tokens? Will that be $1,000 profit? And with flash loans, you don't necessarily need to own the token that you're borrowing when you're buying on this exchange and selling on that exchange. Okay. So, that would be an example of a flash loan arbitrage. I actually just pulled up a transaction because I just saw one float across my screen here earlier. Actually, my assistant Justin tipped me off to this one. So let's take a look here. So here's a real world example of one that happened today. All right. So this is actually from DYDX, example of an actual flash loan transaction in the wild from today. All right. So very recent. That's doing exactly what we're talking about. And it's actually coming from the flash loan provider DYDX that we're going to talk about tonight in our class. Okay. Yeah, totally. Awesome. So let's look at some other examples. You can also do this for, let's see here. You can do it for arbitrage transactions. You can do it for different things in DeFi. You can do it for yield farming, where if that's the example we're going to look tonight. Yield farming is basically where you deposit cryptocurrency to application and you earn high yield. And typically this means through liquidity mining, earning a brand new token. All right, you can use flash loans to generate leverage in that and earn more tokens than you could without using somebody else's money. That's the exact example we're going to show tonight. Okay, we can do it for DeFi liquidations. So basically, whenever you have lending apps on the blockchain where people take out loans, sometimes those loans essentially become delinquent because people are borrowing more than their the value of their assets they have locked into the protocol has maybe declined or for some reason basically their loan is now delinquent. Well, those loans basically need to be closed out, and you can use Flash. You can do that in a decentralized way. Anybody can do it. Anybody can pay back that debt and get a finder's fee essentially for doing it. And you can use Flash loans to sort of pay those back and get that finder's fee all in the same transaction. You do different collateral swaps. There's several other use cases, but those are the main ones. Okay. So let's talk about where we can take out flash loans. This will be sort of the last sort of theoretical thing before we get into some coding here. Let's talk about where you can do flash loans. So I'm going to focus on Ethereum chain for tonight. You can take the strategies that we're doing tonight and you apply them to any EVM compatible chain. That's the beauty of this. We're going to do our examples in Solidity. We're going to do them on the Ethereum mainnet in a sandboxed environment. I'll explain that in a minute. But if you understand how to take out flash loans and how to incorporate them in your own smart contracts, then you could do that on even EVM compatible chain, where basically that means it supports the Ethereum virtual machine. It supports Solidity smart contracts. If you write for Solidity, you can put your smart contracts on Ethereum. You can put it on Binance Smart Chain. You can put it on Phantom, Avalanche, lots of other places. Okay. And a lot of those ecosystems have now flash loan providers as well. So you basically have to just take the existing code we have tonight, adapt it for those flash loan providers. If you're worried about gas fees for taking out flash loans, all type of stuff on Ethereum mainnet, you can apply that to other chains. We're going to stick with the Ethereum main chain tonight so that you can just see everything, how it works, because it's very, very good tooling for that. And I want to do it in a way where you can actually reproduce the steps and then take those learnings and build, whatever you want. So let's start off with our flash loan providers on the Ethereum chain here. So the first one that we're going to use tonight is DYDX. Okay, so DYDX is a decentralized perpetual swap. All right, it's exactly what I was talking about before. It's a DeFi app. It has liquidity pools in the back end, and they have, especially in their version 2, a flash loan provider. And the reason I'm using DYDX over others is because, like I said, it supports the Ethereum contracts, and it also has the lowest fees. Okay, so DYDX does charge fees in order to take out flash loans, but they're basically zero. Like they're less than a penny. Okay, you'll see tonight, but the fees are basically like they don't exist. All right, it's one of the lowest cost flash loans you can do. So you can also do flash loans with Aave. Okay, Aave is a decentralized savings and lending platform. Okay, liquidity protocol. You can do flash loans with that. You can do a type of flash loan with like Uniswap. All right. And there's some more, but those are some of the top ones. All right, so let's explain the coding setup for tonight. So tonight, what we're going to do, we're going to start off. We're going to go ahead and jump into the code here. We're going to start off by showing you how to perform a basic flash loan so that you can see how they work, all right, and then how you can plug them into your own apps. You need to understand these fundamentals before you get to the more complex stuff, because if I just boot up the other app and start showing you the code, your head's going to start spinning and you're not going to know like what to do. So we're going to start off tonight by just observing a flash loan. All right, you're going to take a smart contract. You're going to do it mostly in your web browser. Okay, so you don't have to do a ton of stuff on your computer. We are going to do some stuff on our computer. Okay. And then, like I said, we're going to do this for Solidity. We're going to use the actual Ethereum mainnet, but you can adapt this code, like I said before, for any EVM compatible chain. So tonight we're going to do everything. It's really important to practice your flash loans in a way that you don't have any risk of losing any money. Again, you can't lose money on the money that you're borrowing with flash loans, but you might lose money on gas fees. If you're keeping cryptocurrency in your wallet, there's always risks associated with doing that. And frankly, I just want people that have to pay cryptocurrency to just test stuff out. I don't want to personally do that. Okay. So, we're basically going to practice doing the flash loans in a sandboxed environment so that you don't have to risk that real money. And you can take these exact steps and apply them to a live blockchain later. All right. Now you're going to assume the full risk of doing that. But if you just follow the exact steps that I'm doing tonight, there's no risk because you're not going to risk any real money doing that. So let's see how I can do it. So we're going to use something called Ganache CLI, okay, which is a really, really cool tool for blockchain development. Here's what it does. It's going to let you fork the Ethereum mainnet, which basically means you're going to get a local copy of the entire Ethereum blockchain kind of on your computer so that you can have access to all the apps, all the accounts, all the flash loans, all the cryptocurrency for testing purposes. Okay, so this is going to allow you to develop flash loans without spending any real money. So, you can run a test blockchain on your computer, but the problem is if you're going to do a flash loan, then you need to be able to have a flash loan provider, and those flash loan providers only exist on, real live blockchains. Well, what the cool thing is with Ganache CLI, you can, basically run a test blockchain on your computer and then point it to a real live blockchain out there. All right. And then you get access to all the accounts, all the contracts, all the balances, all the tokens exchanges. And then you can have your local project, talk to this main blockchain by way of this test blockchain on your computer that sort of acts like a bridge that just freezes this. Okay. So, what is a blockchain? A blockchain is a public computer. It's a peer-to-peer network of nodes that always talk to one another. And so if you're gonna take this blockchain or computer and point to a real blockchain as sort of the bridge to your project, you need access to a blockchain node, okay? Because nodes are the redundant computers on a blockchain. If you're going to talk to a blockchain, you need to have access to a node. I saw some comments in the chat about running your own node for like doing arbitrages and stuff. You can do that. It's really hard to run your own node, especially if you're getting out of the box and trying to test things out. So instead of running our own node, what we're going to do is just get access to a blockchain node for free. We're just going to use somebody else's node, which is going to be perfectly fine for development purposes. Okay. So I'm going to walk you through that here in a minute. But let's go ahead and install everything on our computer that we need to get set up. I'm going to go ahead and install all of the dependencies that we need for the entire training tonight. Okay, you're not going to use all these for the first example, but let's just go ahead and knock them out, make the best use of our time so we don't have to get back into that. We're going to set up this entire sandbox environment on our computer so that you can test this out. All right, so let me pull this away. All right. So I'm going to be doing a few things on my terminal tonight. All right. For the first example, we won't do many things on our terminal, but we're going to just use the terminal to, make sure we have our dependencies installed. So let's see here. First dependency that you need installed on your computer is Node.js. Okay. I'm going to put a link to this in the live chat replay in case anybody needs it. So, Node is basically going to be something that lets us run JavaScript on our computer. It's also going to let us install packages on our computer that we need for blockchain development. Okay. So most people who've done some of the master classes in the past have already installed Node, but just definitely know that you need this in order to run, especially our app later. You don't need it for the first example, but I'll just see what Node version I'm using so you can make sure you follow along with this in the class tonight. I'm using 16.14.10. I'm sure another version node will probably work, but if you want to ensure the best results, then I would use 16.14.10, especially if you're brand new. Okay, so the next thing that we need is going to be Truffle. Okay, so Truffle is a smart contract development framework that we're going to use to create our passive income app. Okay, so Truffle is basically lets you develop smart contracts. It lets you write tests against them. It's going to let us connect to that sandbox development environment that I was talking about where you don't spend real money. All right, so I'll see what Truffle version I'm using. Truffle version. All right, if you can run this command on a computer, you have Truffle installed already. But if you don't, after you've installed npm, you can just say npm install --g Truffle. All right, and it should install the latest version of Truffle. All right, so I'm not going to do that right now, but you'll hit enter. That will install Truffle on your computer. Now let's talk about this part of the equation, which is getting a setting up this sandbox environment so that you can actually talk to the blockchain. So again, when you access to a blockchain node, we don't want to run one ourselves. So I'm going to use Infura. Okay. Somebody asked in the chat if you can use Alchemy. You might be able to use Alchemy. Sometimes the nodes work differently. When you're forking the Ganache mainnet, I would say for best results, use Infura because that's exactly what I'm using. Okay. So basically, and also Ganache just released an update where apparently you can just use Ganache straight from the command line and you don't even have to use this anymore. But I didn't want to take the risk of doing that tonight. So we're going to actually show you how to use your own node. It's also super helpful if you want to deploy your contracts to the mainnet. So knowing how to find somebody else's node is pretty important. So sign up for an account for free on Infura. Okay. And you want to go create an application. All right. So that you can get an API key. So I'll put this link in the live chat replay. But basically, this will show you how to create your own app. I don't want to go through the steps right now because I don't want to reveal my, API key on screen. But basically, you could just sign up. All right, create a free account, totally free. And then basically, you can go to Ethereum. You could create a project, give your project a name, and whenever it's done, you'll see this link right here. All right, it's like mainnet.infura.io/v3. And then it's got this, project ID inside of it. And so you want to copy this entire string right here from the H in the HTTPS all the way to the 44 here at the end. You can just click the little clipboard icon and then copy that. Okay. And keep it for safekeeping. All right. So now we have, this part, we have access to this blockchain node. That's this line's going to be. Now we need to set this part. This is Ganache CLI. So Truffle is our project. All right. We're going to do that in a minute. And then also Ganache CLI is going to be our test blockchain, but then it's going to talk to the Ethereum blockchain by way of this node that we just set up. So let's get this last part, which is going to be the Ganache CLI. So basically, you should do npm install --g Ganache CLI. All right, and that will install Ganache CLI on your computer. All right, so I can see Ganache CLI. I think it's --h version. I think it's what I do. Yeah, Ganache CLI version. I'm using 6.12.2. All right. So now, what I'm going to do is actually, start Ganache, like this. Okay. So basically, and I'm going to pull up if you look at the coding resource here. I'm going to pull up the GitHub repository from the, if you look at your coding resources in the video, hold on a second here. Let me pull up the GitHub repository here. want to show you the command for starting the project. That's okay. I'll just show you the command in my terminal. I don't see it right now for some reason. So basically what you're going to do is you're going to go to your terminal. You're going to type ganache CLI, all right? And then you're going to paste in, or you're going to type this in. Ganache, I'm going to bump this up on my screen so you can see it okay. It should be in the README of your project. I just can't see it properly. Ganache CLI -P, which stands for port 7545. And then you're going to put in this, https mainnet inferior.io/version3, and you're going to paste in, this exact string that you see right here. Okay. So I'm going to just do mine off screen here. All right. And you'll see what happens when it gets started. All right, so mine started, and you'll see what it looks like whenever you have it on your screen here. Let's see here. I think I might have just revealed my key. It's not a big deal. I can just delete that app. But anyways, whenever you see it started, you'll see this. You'll see, the accounts and your private keys. Okay, you're gonna see a mnemonic on there. You can see sensitive information like the private keys. You definitely don't want to use these private keys or this mnemonic for any real cryptocurrency. All right, do not store any real money in these accounts because everybody's watched this video, has seen these. All right, I'm not putting any money in these accounts. And if these ever show in plain text on your developer terminal, you should never store any real money inside of them. Okay, this is just just 10 accounts that we've been given for free with 100 fake crypto for 100 ether for free, fake ether inside of our project. Here's the private keys for them. But this is going to be the sort of boilerplate for our sandbox environment that we can use to start, doing that. Sometimes Ganache CLI is deprecated. So that's because Ganache version CLI, just the newest version, just came out. It's Ganache. That's what I was saying a minute ago. You can still use Ganache CLI. It works just fine. We're sort of in this transition period, and we just want to make sure we have the tools that work properly inside the masterclass tonight. Okay. If you want to try to upgrade to Ganache without the CLI tool, then by all means, go ahead and give that a shot. But we're just going to show you exactly what works tonight. Okay. So let's look at now that we have this running, let's go ahead and I think I just showed the key on there. It's okay. Again, I can just delete that app. It's not a big deal. So now let's go ahead and do the basic flash loan contract. What I'm going to do is go on over to remix.ethereum.org. All right. So this is a browser-based IDE that's going to let you create smart contracts inside your browser. All right. So you can see that you can put smart contracts inside of here. You can compile them. You can run them. All right. And so we're going to use Remix to do this first flash loan. So basically what we're going to do is, now that we've got Ganache set up, we're going to open Remix, and here's what we're going to do. Let me show you the diagram. We're going to basically take a flash loan from a DeFi app. It's going to be DYDX, and we're just going to bring it into our own custom smart contract that we're going to paste into our browser. That's all it's going to do. You could use this to go do other things like trade, do DeFi, liquidations, whatever. We're going to see concrete examples of that here in a minute, but this is just the basic smoke test that's going to show you how to do it. And we're going to borrow $1 million of cryptocurrency and demonstrate how you would do that with the flash loan in your browser. So it's going to borrow $1 million from DYDX, give it to your contract, and then your contract's immediately going to pay it back. Okay. And that'll be your sort of your rite of passage for doing your first flash loan. Then we'll show you how to implement them in more complex ways. So go ahead and open the code from your coding sample down below. Again, you should have a zip file wherever you're watching this video. Unzip that, open it in your text editor. You can use whatever text editor you like. You can even open it just as a folder on your computer if you don't have a text editor yet. Go to the examples folder and look at the flashloan.sol file. Okay, this is a Solidity file that we're going to use. So go ahead and copy this. Copy. Go to Remix. All right, create a new contract here. Open the contract. Click this little icon. Create a new call for, or it doesn't really matter what you call it, flash loan.sol, capital F. All right, paste it in here. And now you've got the source code for your flash loan. All right, we're going to go over the code shortly in a minute. Okay, but for now, let's just observe how it works. So paste it in there. All right, then go to compile. It's this next button down here. All right, and then we're going to choose the compiler version. I'm going to use version, 0.5.1. I'm just gonna work on a second. Okay, so if you hit this error, click this unimplemented feature. Actually, let's 1 second here. Compiler version. Let's see here. Okay, so we actually had this little bit of an error earlier today. Remixes has just changed its interface. Hold on a second, everybody. This definitely works. Hold on, everybody. Hold on a second. See if I can get Justin on the chat here. Justin, if you're watching this, let's see here. Basically, the frustrating thing is sometimes Remix changes its options. Let me just do include nightly bills and see what happens here. Okay, let's just try this. Flash loan. Normally, you should be able to like tell it which one you want to use. Yeah. Okay, hold on, everybody. Let me see if I can do it in my other. Spend it in my other tab. All right, so flash loan is still. Oh, hold on a second. Did that change anything? All right. Okay, so I got it working, everybody. I believe, hold on a second, 0.5. Okay, I got it. 0.5.16. If for some reason it just decided not to show me all the compiler versions, let's take off nightly bills. 0.5. Well, hold on, let's click back in. So sometimes this stuff happens. Remix decides to change the interface. So if you click on nightly bills, you can do 0.5.16. Okay. For some reason, whenever I chose the option before, it didn't show it. So now we have the proper thing here. Click compile. And boom, there we go. Awesome. So it worked. Sorry for the hiccup, everybody. This is software development. This happens, especially when the tools decide to change. Sometimes it's actually helpful to run into these errors in real time and then debug them so that you can see what it's like to be a real world software developer. All right. So the contract has compiled. All right. You want to click on, contract flash loan. All right. You can see this warning here. That's okay. It uses this ABI experimental encoder. That's not a big deal. Now we want to do is actually deploy the contract. Okay. So we're doing everything in our browser right now. All right. We're in Remix. What we want to do is take Remix and actually point it to this sandbox blockchain environment that we created in the previous step again, right? So we want to basically use this thing. And this thing here is on our computer. It's not inside of our browser. So what are we going to do? Well, we're going to use MetaMask, okay? So if you go back to Ganache, you can basically take, any of your private, you can go back here and then look at any of these, private keys that are in your wallet here. Or you can copy one of these private keys. It's got 100 fake Ether in it. And then you go to your MetaMask wallet, right? You definitely have MetaMask installed in order to do this. But you can basically, import, you can import your account to MetaMask. So I pull up my MetaMask so I can import the account. So for MetaMask, you'll click on it. You'll do import account. Click on accounts, then do import account. All right, your private key, paste in your private key from Ganache, and then there. All right, and now what you want to do is actually change your networks to Ganache CLI. So I've already got Ganache CLI, but you might have to add network here, and you'll probably see this type of thing pop up. All right, you'll see the network name. You can call it Ganache CLI. RPC URL will be the RPC URL from this. It'd be, localhost like this. Right. And then this is the settings you want to enter. Basically, Ganache CLI 127001, chain ID 1337, and the symbol is going to be ETH. All right. So I've already done that, but I'm going to just connect this here. All right. And then I'm going to basically use Ganache CLI. And then once I switch to Ganache CLI, I should see my, Ether balance reflected here. Yeah, there you go, 100 ETH. All right, now you're cooking with gas. So you've connected MetaMask to Ganache CLI. And now what you're going to do is actually deploy the smart contract with MetaMask through your browser to Ganache CLI. So we're going to deploy it like this. We're basically going to choose injected Web3 provider. Okay, so environment, click injected Web3. It says main right here. It says mainnet. That's because it thinks it's the Ethereum mainnet because that's what Ganache CLI is using. Okay, but if you're connected to Remix and you see, Ganache CLI here, not Ethereum mainnet, then you know that you're talking to the right place. You see your account has 100 Ether in here, unless you're just, casually slinging around 100 ETH in your regular MetaMask wallet. You shouldn't see that. All right, so that looks right. I guess what I'm trying to say. So now what we want to do is actually fill in this value field here. All right, so we're going to use this to pay the flash loan fees. So DYDX, let me explain this. DYDX does charge fees. And what it does is it charges a fee that is equal to one way of the cryptocurrency you are borrowing. So let me explain that really quickly. So we're going to borrow a flash loan tonight with Ether or wrapped Ether. So wrapped Ether is an ERC20 token version of the Ethereum cryptocurrency or Ether. Okay. And Ether is divisible by 18 zeros after the decimal place. So what I mean by that is basically if you were to write, look at $1, it looks like this, 1.00. $1 has 100 pennies that make up a dollar, so you write it 1.00. All right, but Ether has 18 zeros after the decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 18. And, this is not called a penny, it's called way. Okay, so, for this right here, it's called 1 penny because 100 of these make up a dollar. And, this right here is called 1 way because at times however many it takes to make up 1 is 1 ether. Okay, so we can observe that here on a site like ethconverter.com. So you can see 1 way is equal to this many ether, and 1 ether is equal to that many way. If you see gas prices expressed in gwei all the time, like 100 gwei is that much way, and it's that much ether. Okay, so the reason I'm bringing that up is DYDX. Anytime that you take out a flash loan, they charge you fees in 1 way of the cryptocurrency that you're borrowing. So if we're going to borrow ETH or WETH, then if you're going to borrow like 1, it doesn't matter how much ether you borrow. It's just going to charge you 1 way, per. It's just going to charge you 1 way per flash loan. So it doesn't matter if you borrow 100 ETH or 1 ETH every single time you take out a flash loan. It's not a percentage of the loan amount. It's just a flat fee of 1 way, which is the smallest amount of cryptocurrency. So we're going to say 10 way here is the value. Because what we're going to do is we're going to actually send some ether in with our smart contract when we deploy it. And when we send, 10 way in there, that's actually going to deposit 10 ETH into our smart contract, and it's actually going to convert it into WETH automatically. And then that way, whenever we deploy it, we'll have 10 WETH sitting in the smart contract that can pay the fees for the flash loans. Okay. So basically that just means that we'll be able to take out 10 flash loans if we wanted to, 10 different flash loans, because we have 10 way in the smart contract. And every single time we're getting charged 1 way. All right. So that's why we fill out the value of 10 way here. All right. So now we have the network, we have the accounts, we have the gas limit, we have the value, we have the smart contract we want to deploy, which is flash loan. All right. Not DYDX flash loan, but flash loan. All right. We have the value set in. And I believe that's everything. Let's go ahead and click deploy here. All right. So now you see a confirmation pop up here. Just ignore this gas estimation and the gas limit. It's not completely accurate because you're using Ganache CLI. Let's just click confirm. You'll see the MetaMask confirmation pop up. All right. You'll see the estimated gas fee. Again, this is all fake money, so it's not a big deal. And then boom, there you go. All right, it's done. So now, let's actually take out the flash loan. Okay. So now in Remix, you can see this here. You can see the functions. We're going to use this function get flash loan. All right. And what we're going to do is tell it which token we want to borrow and how much. So we're going to borrow $1 million worth of ether. Okay. So in this case, we're not using ETH, the actual cryptocurrency. We call WETH, which is wrapped ether. It's the ERC20 version of ether. So it's a token, not the native cryptocurrency. And so we can see the WETH address here. You click this blue button. It's already hard-coded into our smart contract up here, okay? And so we have this nice little button that reads that from a function, and we can just copy it, and we can paste it into the flash token. And then the flash amount, we want to borrow $1 million. All right, so basically we can use our ETH converter. All right. And then we can also calculate the Ethereum price. So say 1 million. 1, 2, 3, 4, 5, 6 USD ETH. All right, if I do $1 million USD to ETH, that's 367 Ether at the current Ether price. Let's just round up. Let's go 370. So we'll borrow more than $1 million. So 370 Ether. 370 ether is this many way. All right, so that's 370 with 18 decimal places after it. So whenever you're taking out the loan, you have to express it in way, because the reason we have way in the first place is because we don't want to. Smart contracts don't use decimals. So we don't handle fractions at the smart contract level. So you express everything in whole numbers, and then you have to do the math to like round it out, or do the math outside the smart contracts themselves. So basically, if a flash amount, you just paste in that amount. So it's 370 with 18 zeros after it. Click transact, and then you should see the confirmation pop up. Again, these values are wrong. Don't worry about it. Click confirm on MetaMask. And boom, there you go. All right. So you have just performed a flash loan on your sandbox environment. Now, there is something left to be desired because you can't actually see what happened with the transaction. I mean, you might click this and say, oh, awesome, I want to see this like on Etherscan, right? But if you go to Etherscan, like it's not actually going to take you to a real transaction. That's because you're doing this in a sandboxed environment. It doesn't. Etherscan's not going to pick up what you do on your computer. Again, you have access to all the apps and data and stuff like that on the blockchain. But let me show you what the Etherscan successful transaction would look like, because I have done this on the mainnet by performing this exact flash loan, and so I'm going to show you, what it would look like if you perform this successfully. So it basically would just look like this with the exact code that I'm showing you right now. So basically, this is, you see a transaction looks like this. It's basically borrowing. I borrowed a lot more from the last example. We did 370. This was 4,000 ether. All right. So right now that's $11 million. So this is an $11 million loan. So basically borrowing $11 million, you'd see this instruction from DYDX, that's the exact flash loan provider we just used, to this smart contract that we created for this example. All right, this is the exact example I just showed you, and then you'd see it go from your smart contract back to the DYDX solo margin provider, and then you'd see that there was just this little tiny transaction fee. You see it right here. Here's your transaction fee, right? You borrowed this much, but then you returned this much plus this tiny, 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 tiny minuscule fee. And so that's what I was saying before, is like the DYDX flash loans are basically free, okay? Because this amount of money here is just not even worth counting. It's like less than a penny. It's like even like not even close to a penny, right? And so you just have to have some ether to pay those fees, right? But it's such a tiny, negligible amount, it's like basically free. But you technically have to pay some fee in order to do it, okay? So that's what a basic flash loan looks like. I'm going to walk through the basic code of that here in a second, but that's a good sort of stopping point for 2 seconds just to kind of catch your breath and feel a sense of accomplishment here. All right, I'm going to get one more glass of water because my voice is starting to get a little hoarse. I'll answer like 2 quick questions, and then we'll continue with our presentation here. We'll look at the code, and then we'll set up the second app. All right, so can this be on the mainnet too instead of Ganache CLI? Yes, it definitely can. But as I was saying before, there are lots of risks associated with doing things in the mainnet. All right, not necessarily for just a simple flash loan, but I want to clearly outline what those risks are for this particular example. So basically, for the current example that we just did, what are the risks? Well, doing it in the sandbox environment, there's no risk. but basically, if you're going to do it on live blockchain, then basically, there's no risk you can lose the money. Like you can't, like, if I just borrowed $11 million on my screen here, you can't lose that $11 million like we explained before. But if you're keeping, cryptocurrency in your wallet to do this, there's always risks of moving cryptocurrency around inside your own wallet. It's called custody risk. You could lose any of the cryptocurrency that you, take as profits or any cryptocurrency on your wallet. If you're trying to pay gas fees and you fail to deploy your contract to the network, you could have issues there. If you try to do a transaction that fails, you could lose money on gas fees there. There's always risks. Okay, let me be very 100% clear about that, and you have to, understand the competence to you just gotta be careful. So I want to make you well aware of those risks before you try something like this at home. All right, so let's look at some other. Let's look at the next thing here. Let's actually look at the code for this and talk about how it works. So let's look at the code in our browser. It'll be much easier, or in our editor here. So this is our basic Flashstone example. So how does it work? So the nice thing about our editors, we can use minimizing these types of things. So first of all, let's look at our actual smart contract here. It's at the very bottom. So basically Flashstone, it's a pretty simple smart contract in and of itself. We are going to use the template just like DYDX has told us to do. All right. So basically, you can look at contract flash loan. This is our contract. And we use inheritance and solidity to say it is a DYDX flash loan. So honestly, you don't even really need to worry about what's happening inside this contract DYDX flash loan. This is literally code that's copied and pasted from the DYDX implementation itself. So if you look up how to do flash loans with DYDX in the documentation, like this, this is really just like, this is just copy and paste. I didn't write this code, so you don't have to worry about it. ERC20 is really just an interface for ERC20 tokens. This describes how all ERC20 tokens work and just the functions we need. We just need to get the balance of a particular token and also approve tokens so that we can send them around. Okay. DYDX pool and the structs are really just things that we need to make the smart contracts work. So these are all just libraries. Okay. Libraries are just pieces of code that you don't have to write yourself so you can create applications quickly. That's what all this stuff is up here. So don't even worry about that. And likewise, these functions are really just what, DYDX tells us to implement on our contract. Okay. So let's step through step by step. So basically, we have this thing called a constructor function, which is the function that gets called whenever our smart contract is put on the blockchain. It gets called once and only once. Okay. And so basically, you can say constructor public payable. Basically, this means you can send cryptocurrency when you deploy the contract. And now you'll see this first line that says WETH call value message value. So what does that mean? Well, basically, WETH is a smart contract that controls the WETH token. And you can wrap Ether to turn it into an ERC20 token. So what we do is we send Ethereum cryptocurrency or Ether in whenever we deploy the smart contract with this constructor. Again, in Remix, we saw that. We fill out that value field. And whatever it sent in right here, we did WETH call. And whenever you do call and you send the value and you put in message value, this takes the cryptocurrency that we sent in with our transaction and it instantly sends it to the WETH contract. And whenever you do WETH call and you give it some Ether, it just instantly sends you wrapped Ether back. Okay. And so that's what happens here. And then if that doesn't work properly, we have this thing that says, failed to get WETH. Right. So it says how did I view that on Etherscan? So that's a transaction that I've actually done it before on Etherscan. I just pulled up an old example. So yes, it's $11 million. It's kind of an arbitrary calculation. It's not the same thing as the $1 million transaction we just did. So that's what I was saying. You can't, if you do it in the sandbox environment, you're not gonna be able to see this stuff on Etherscan, but that's an example of what it looked like. All right, so So that's what the constructor is. Now let's talk about the get flash loan function. So basically, this is a function that we've coded. We tell it which flash token we want to borrow. That's the one we're going to say WETH in this case, and the flash amount. And this is how much WETH we want to borrow. And then we just track the balance before. All right. We keep track of the balance. And then we call the flash loan, which is provided by DYDX. All right. And we tell the flash token, flash amount, and the data that we want to execute after the flash loan gets taken place. And so DYDX tells us how to do that here. Okay. And you can see that's exactly what they ask us to do. Right? You see the internal, this is the flash loan function, token, amount, all right, data. All right. And then here it does its entire flash loan. I don't know. You explain all this code. I don't even personally understand everything that happens in this code. It just does the flash loan. Okay. It's all you need to know, as long as you have those variables. And so then DYDX requires that we implement this call function in our smart contract. So right here, we're calling the DYDX smart contract. And then once that's done, the DYDX contract calls back to our contract. It tells us we have to implement this callback function called call function. All right. And basically what it does is it passes in these variables. And then once it comes back, we have the money. Okay. We have the money to do the flash loan. All right. And then now here's the loan that we got back from DYDX. And now this commented out line here, use the money here. This is where you'd write any custom code that you wanted to trade on an exchange, to do DeFi, to cancel out a loan, for liquidations, collateral swaps, whatever you want to do. Like, this is where you would do it. And this is your jumping off point to write your own applications. Okay. That's what I really want to show you. All right. How to get started with this basic flash loan contract. And you could use this as a template, start writing your own applications. And that's sort of the jumping off point. All right. So now I'll pause for just like 2 seconds, and then we'll actually jump into a real world application where we have actually taken this template and then put it to work. And you're going to see a full coding implementation that actually works. You can turn on and it prints money. So here's a good quick question. I'll answer this. Somebody says, what needs to change if we want to use other flash loan providers? Well, you would basically have to implement their entire flash loan interface. So you'd have to pull in, their smart contracts. You could probably use a library for that if you wanted to. And then you'd have to implement that into your own smart contracts that way. Somebody says, look at other flash loan provider docs. Yes, definitely. But the good news is, if you go through all the examples tonight and you truly understand how these flash loans work, and let's just say you don't even decide to use the application tonight, you know what I mean? Like, it's totally fine. Like, part of the whole purpose is to get you understanding how do you put all these pieces together to create something useful. Okay. And I'm going to show you the thing that's useful tonight. Now, again, there's risks associated with of the solution that we're going to show after this. I always want to highlight those risks because inevitably there's going to be somebody who, does not heed the warnings. So I want to highlight those, for sure. But you can do lots of different things. Okay. And you can take this code and then use it and learn it and understand it and create lots of different things besides the solution tonight. But we want to just have something out of the box that you can run, instantly get feedback, see that it works, and then show you what you can change in order to create your own projects. Because that's ultimately what you want to do if you really want to have an edge, is gain the skills for yourself and then that ability to do something else with them. So can you always be successful when you have flash loan? Does it fail sometimes? The only reason it would fail is if your transaction just doesn't happen to go through. I mean, with the code that I just shared with you, the code's always going to work. But if you don't pay enough gas, you get the gas price wrong, that's always a risk. Especially as you have to keep the browser open to keep the bot running, or do the trades? Can you sleep and turn off your computer? Or keeps going? So basically, the application for a minute, the passive income app, it just lives on the blockchain. You don't actually have to. You don't have to keep anything running. So I'll show you that. All right, so let's go ahead and jump into the next example. Let's talk about how to actually, do a full application with this. Again, we just saw this sandbox environment with our Ganache CLI. We're going to keep Ganache CLI open. All right, but we're going to actually move on to the other part of our code, which is going to let us build in the source directory, which is going to let us generate a full application with everything that we showed tonight in this template. So let's explain how it works. All right, so let's create a passive income app. All right, so an app that literally, if you return on the mainnet, it would start just start printing money. Okay. Now, again, there are going to be risks associated with this thing that I'm going to show you here. I want to be very clear about what those are. But let's put it into practice. So I had to create your own app that's going to let you do yield farming. Okay. And it's going to let you multiply your yield farming rewards with flash loans. Okay. So let's just break that down. Let's first talk about, what is yield farming in the first place. All right. So yield farming, is a yield farming or liquidity mining. So what is it? So basically in the previous section, remember how I talked about how, DeFi apps use liquidity pools to power their applications, and how, decentralized users can basically park money into these liquidity pools because those apps need money to run, right? And the decentralized liquidity providers are incentivized to deposit this money because they can earn passive income rewards for doing this, okay? So the income that they get is yield, okay, expressed in like annual percentage yield, like APY. And these, yield farmers are constantly chasing the highest yields, okay, from application to application. So many times, these DeFi applications will also offer these liquidity mining bonuses where they have incentives where you're not just, like let's say you deposited DAI cryptocurrency into an application and you're earning passive income paid out in DAI tokens, okay, for doing that. That's your incentive. Well, sometimes they'll offer additional incentives by saying, hey, we're going to issue a brand new cryptocurrency. The protocol we're going to see tonight is the Compound Finance Protocol, COMP protocol, and you'll get paid out, COMP tokens. So if you deposit DAI, we'll give you some passive income in DAI, but then we're also going to pay these bonus COMP tokens for depositing money into our application as an incentive, because we need money. So we're going to give you a brand new cryptocurrency. So you'll deposit DAI, you'll get some DAI back, but you'll also get this brand new token called the comp token. All right. And so you're going to earn yield in two ways with the same cryptocurrency, and then also a brand new cryptocurrency. So we're going to do this with Compound Finance. All right. So let's just pull up. All right, so Compound Finance, what is it? So Compound is a savings and lending protocol, right? It's a decentralized application. It's powered by smart contracts. It runs on a blockchain. It's a savings and lending app. Okay, so basically, you can deposit cryptocurrency into the application. All right, you can see it's got all your cryptocurrencies here. It's got DAI. It's got, USDC, it's got Way, it's got Ether. I said Way. It's got Ether, it's got Sushi token, all this stuff, Aave token. All right, and you can see, like, say, if you bought DAI, for example, you can earn 2.45% on your DAI cryptocurrency. All right, so you can deposit money into there, and then you can also turn around and borrow cryptocurrency on the other side. All right, so it works like a bank. You deposit money, and you can earn. And you can borrow money, and you can just pay interest for doing that. Okay. So, whenever you borrow money on the other side, okay, you must deposit. And you can deposit on one side, you can borrow on the other. And whenever you deposit, you earn, the DAI plus comp token. So comp is the native cryptocurrency of comp. They pay you out as an incentive for doing this. They pay you whenever you deposit, and they also pay you when you borrow. Okay. So now the catch with comp is that, in order to take out a loan, you have to post collateral. All right. And so that means basically in order to borrow money, you have to deposit cryptocurrency application, and you have to deposit more cryptocurrency than what you borrow in US dollar terms. So you might say that's really strange. Like, why would you want to do that? Why would you want to take out a loan? Why do you need money to take out a loan in the first place? That's kind of strange. Well, there's lots of reasons why you want to do this. You might want to borrow against your own assets to avoid triggering a taxable event. You might do it for like shorting cryptocurrencies, but you also might do it for enhancing these liquidity mining incentives like I'm talking about here in this presentation. So the cool thing about this is you have a huge edge as a developer that other people don't have when they're using Compound, because let's say I wanted to maximize my yield farming rewards in Compound. What would I do? Well, I might deposit cryptocurrency and start earning comp tokens for doing that. But then I might turn around and borrow some additional cryptocurrency to also earn comp tokens. Yeah, why wouldn't I want to get bonus tokens? Wouldn't that be cool? But there's a kind of a limitation here. When you're depositing through the interface, you always have to borrow a different cryptocurrency than one that you're depositing. Okay, so if I deposit DAI, it's not going to let me turn around and borrow DAI. I'd have to borrow some other asset. But because comp is it's powered by smart contracts, it's on the blockchain, you as a developer are able to basically, you have open access to this financial system. You have open access to Compound smart contracts, and you can do things that you can't necessarily do through the UI. Okay, it's not bad. It doesn't mean like Compound doesn't want you to do this. I mean, I've been in Compound's Discord servers. They're well aware that people do exactly what I'm showing you in this video. So it's not like bad or anything. But basically, what you can do as a developer is you can write an app, you can write a smart contract that deposits DAI and then turns around and borrows DAI. Okay. And then you get bonus comp tokens for doing that. Now, what's even cooler is you can deposit DAI and then you can increase the amount of DAI that you deposit with flash loans by about 3 times. Okay. And then you can turn around and instantly borrow the money back and pay back the flash loan, and you can increase the amount of exposure you have into the application, and you earn a lot more comp tokens than you could have without doing that. All right, so let me show you in a diagram how this works. Okay, so basically, this is what our app's going to do. So how it's going to work right now, let's just use a simple example. All right, let's use a really simple example for easy numbers. Let's say that you're just going to deposit $30 worth of DAI in this application. All right. Just for super simple sake of explanation. Basically, you have to use some of your own money. All right. So let's say you start with $30 of your own money, and then you can multiply your exposure with a flash loan. So basically, you take $30 of your own DAI, and then you take out a flash loan for $70. All right. And then you put it into the liquidity pool. All right. Now you have $100 sitting in the liquidity pool. And then you turn around and borrow $70 back out. And then you instantly pay back the flash loan. And now you have $100, of exposure into the Compound protocol. And you're getting rewarded for depositing 30 and borrowing 70. And you're getting, you're getting rewards for doing that, all right, that you would not normally be getting if you weren't able to use flash loans, okay? So that's how you do it. That's the deposit step, is you take $30, you borrow 70, you put it in the application, you instantly turn around and borrow it, and then now you've got your $30 stuck in the application, but you're getting credited for having deposited 100 and borrowed 70. So you're getting way more comp tokens. All right. So that's how you deposit your money in there and increase your exposure. Now, how do you get your money back out? We do the exact opposite. Basically, you take out a flash loan to pay back the loan. All right. And then you pull your money back out. You get your principal back out. You get the flash loan back and you pay the flash loan. You also withdraw your compound rewards. Okay. So that's how it works. And you're able to get way more comp tokens than you could before, without that flash loan. So let's actually look at an illustration to see how that works. Okay, so let me explain why I chose these numbers in the first place of 30 and 70. I just use them for really easy numbers. Okay, so first of all, it's super easy numbers to illustrate the point. Your numbers may be way different than that, but it's all about percentages so that you can easily see that 30 and 70 equally add up together to be 100, which is super easy for percentages. So using $30 of your own money and $70 of borrowed money. So this is what's called represents a 70% loan to value ratio. Okay, because the total value of the deposited and the contract is $100. All right, and the loan amount is $70, and the principal, which is the money that you have, all right, is $30. So I used 70% in this case because compound finance has something called the collateralization factor, which basically is their maximum loan to value ratio that they will offer. So their maximum loan to value ratio is basically 75%. So I backed the example down to about 70%, just so that it has a little bit of headroom so that you're not maxing out the loan. Because if you max out the loan and there's any sort of like fluctuation in interest rates, then you're in liquidation territory. Okay, so I backed it off a little bit. And so basically that means if you're doing a maximum collateralization factor of 75%, that means for every, $1 US, you can borrow a maximum of 75 cents. All right. And so I'm going to say slightly below that, just to be super safe, for example, and know that it's going to work without any potential fluctuations in interest rates. Okay. So, you can calculate, when you're doing this, basically, with compound, you're earning bonus comp tokens. We can see how that works in a second. But the interest rates, the good news about this, you're using stable coins. Okay. So the good news is the price of the assets will not really fluctuate enough to be a significant risk. Like if you're doing this with a very volatile cryptocurrency, it'd be way riskier. Now, a stable coin, the price doesn't change, and the interest rates essentially end up canceling each other out with the deposit and the borrow in many cases. Okay. So you're not really going to be earning significant rewards in DAI terms. You're really your rewards are mostly going to come from your rewards are mostly going to come from the compound tokens themselves. You're not going to get much rewards from DAI. You're mostly just maximizing your compound rewards. So let's look at how you kind of calculate that and how you can actually get those. So basically, you can see how Compound distributes their tokens. So basically, Compound rewards are calculated per block, okay? And then they're distributed across every single asset in the protocol. So you can see the daily comp distribution here, all right? And then you can see how much is distributed across every single, you can see how much is calculated across every single thing here, okay? So you can see that for depositing DAI, here's the per day distribution. Here's the per day that you get for supplying. And here's the per day you get for borrowing. Okay, so you get a lot more for borrowing than for supplying. Now, it's kind of hard to calculate exactly what you're going to get in terms of returns because for a couple reasons, a couple big variables. The the APYs go up and down on a daily basis for lots of different reasons. Okay, because they have a fixed amount that distributed across every single day, but the composition of the pools changes a lot. So basically, it divides it evenly across all markets, which means, or based on who's deposited in all the markets. Okay, so different markets earn more comp rewards than others. Okay, but then inside of each market, your share of the reward is relative to the size of your position in the entire pool. So basically, let's say that, just for easy example purposes, the die pool has $1,000 in it, right? And then you put in your $30. Well, then you're earning 3% of that pool's rewards for the day. Okay, so for depositing, you'd get, you'd get 3% of 830, right? Just for example purposes. And then likewise, if you have more than that, you get a greater percentage of that. But that could always change depending on who's in that pool. So it's hard to truly tell exactly what your rewards are going to be on a daily basis, because those factors can change and the interest rates can go, or the APYs can go up and down. So the best way to do this, honestly, is to use the sandbox application I'm going to show you here in a minute, to actually run it in a sandbox environment, and then just see what your position size is, and then use like history to see like what that's actually going to do. Like use the history to see what your reward actually is, and then that can kind of give you an idea of what you could roughly expect on a daily basis, and then average that out based on your position size. Okay. So, but the thing I do want to illustrate here is how you can increase those rewards with flash loans versus without. So basically, without flash loans, you're depositing $30. Let's assume that the compound pool is $1,000. It's way bigger than that. We're just using we're using $30 as an example. Well, you'd be earning 3%. All right, but that's without flash loans. But if you use flash loans, and then you borrow the $70 additionally and add it to your deposit, then you're up to $100, which is 10% of the pool, which is roughly 3 times, the returns. A little more even. So that's how flash loans can increase exposure and increase the profitability of this opportunity. Okay. So now, let's talk about, we're going to set the app up, but let's talk about the risks involved with this, okay? Because there are risks associated with this particular thing. Again, we're going to show you the sandbox environment, but I'm going to tell you exactly what the risks are for this particular application that we're going to wire up tonight, okay? So should you try to do anything like this in the real world? So basically, you are using some of your own money in this case, all right? There's zero risks in doing the example that I'm going to show you tonight step by step, but if you take it beyond that, there are risks. And here's what it is. If you're using your own money in the real world, you have to deposit some money, but you're using flash loans to increase the amount of money that you're depositing into the protocol. Okay. So if anything goes wrong in that situation, then you could potentially lose that money that you're depositing. You can never lose the money that you take a flash loan out from. But if you mix that with your own money, then the own money that you use could, potentially be at risk. In addition to the risk we talked about in the previous section, gas fees, holding cryptocurrency in your wallet, all that stuff. There's always going to be smart contract risks. Okay. Basically, depositing into something like Compound Finance. Compound is a very tried and tested protocol in terms of blockchain standards, but there's always risks when using blockchain smart contracts like that. Okay. And creating your own smart contracts, there's always risks, stuff like that. Now in terms of the actual protocol, when you are talking about borrowing money and using leverage, we use a collateralization factor, a loan to value that's below Compound's maximum collateralization factor of 75%. We're using 70, but if there's any fluctuations in the interest rates, that get too high, okay, then you could potentially be in liquidation territory that could compromise this, principle that you use inside the application. You can mitigate those risks by using less leverage. You could use 50% leverage, right? You could back it down to 35%. Even if you wanted to, that's going to decrease the profitability, but it's safer. Okay, but those are the risks involved. All right. If you decide to do it with volatile assets, it gets way, way, way riskier. That's why we use stable coins in this case, because those, prices on the principal themselves are not really going to change that much in terms of US dollar value. Okay. So can you use Aave? Yes, you can use Aave. Okay, so somebody says the rewards will accrue per block, but our transaction will be active for one block due to the flash loan. So there's two transactions involved here. There's a deposit transaction to deposit into the application. And once you do that, your principal is sitting in the application until you decide to withdraw it. Okay. So you deposit it, use flash loans, and then you turn around and withdraw it. That's that you wait for a while to withdraw it, and then whenever you withdraw it, you'll get the money back, and then that's how that you earn the passive income over time. Okay. So have I executed a successful flash loan? I've never heard of him. I just showed you a successful flash loan transaction that I just personally did. Can you do this on Polygon? You can do flash loans on Polygon. You can't do DYDX on Polygon. You have to adapt the provider. But there definitely are apps that you can do the yield farming on. Okay, so let's set the application up, all right? And let's run it. Let's see how it works, and then we'll break down the code. So go ahead and open the code, your terminal here, and you want to install your dependencies. Okay, I'm going to do yarn install. All right, so we're going to use yarn instead of npm. Your step probably might take a lot longer than that. I've already installed mine on my computer. But basically, what we're going to do is use these contracts inside of here. So contracts, leverage, yield farm. We're going to go through the code here in a minute, but basically, I'm going to show you with a script how you can run this with Ganache CLI, on the, against the actual compound protocol in this sandbox environment. So we're going to do this all inside of a test, okay? So you can take these exact steps and do them inside of Remix, like I showed you in your browser before. You can literally just compile the contracts, flatten them, copy and paste them, put them in a Remix, and run it in your browser if you wanted to. But we're going to do it with a test just to, remove some of the steps, and just like watch it. And we can also wait for the rewards to accrue, and then we can withdraw them. We can watch it in a script, watch it happen in real time, completely automate the entire thing, make it a lot easier. So inside the test directory, we have this yield farm test, which is going to do all the steps. We'll explain these. All right, but let's just run it. Okay, let's just go to our terminal here. We truffle test. Again, we already installed truffle. It's going to compile the contracts. You'll see some verbose output. That's okay. But now you see the test running. All right. So the leverage yield farm is running. All right. It's waiting a second so that it can actually accrue interest. And you'll see the output here whenever it's finished. All right, there we go. Boom, it worked. So you might be like, okay, what worked? What happened? So let's kind of step through it here. So basically, we have an output of what we just did on our screen. We just did everything that I was talking about inside that diagram. Okay, we took DAI cryptocurrency. We put it in a compound finance. We took out a flash loan to multiply our exposure. All right. We waited for 10 seconds. All right. And then we withdrew all the money, paid back the flash loan, took our DAI out of our smart contract, and then also took the comp rewards and put everything back on our wallet. So we're going to observe all that in the code here in a minute, but we have a successful log of all that on our screen right here. And we can see the summary. So here's our Ether balance in our wallet before. It's quite high. Here's the ETH balance after. Okay, we paid some fees here. So here's our DAI balance. Okay, so we had $2,668.53 in DAI before. Okay, or so $2,688. Sorry, I misspoke. And the DAI balance after was $2,689. We get $1 more after 10 seconds, which is pretty awesome. Good casual dollar every 10 seconds, not too bad. And then the CDAI balance after, CDAI balance before was this, and the CDAI balance after was that, which is okay. And the comp balance after, which is the thing that we want here, is this. Okay. I might just do a little calculation here. All right, so this is the amount of compound tokens we earned in like 10 seconds. So it's a pretty small amount of money, right? It's basically a negligible amount of money. But we can see that we are actually accruing comp rewards even after 10 seconds. Okay. Now, if you left this in here a much longer time, of course, this number would get a lot bigger. And that's what I was saying before. One of the best ways to do this is to run the simulator over a certain amount of time. You can actually manipulate the amount of time of the blockchain, which we'll see here in a minute, and then see how much those rewards end up being. You can do things like change the variables about how much you would deposit into the application. But you can see with this test that it actually works. Okay. So I'm going to go through the code here in a minute, explain it. We'll go through all that. So somebody says that pay back the flash loan before waiting 10 seconds or pay back after withdrawal. So I did it twice. We do flash loans twice. You do the flash loan whenever you deposit because you're increasing your exposure, and then you pay it back instantly. So you have two transactions. You have a deposit transaction, and then you have the withdrawal transaction. So you perform a flash loan in both of those cases. You perform a flash loan when you deposit because you're taking, from our previous example of 30 and 70 up to 100, you're depositing $30 your Mo money. You're taking out a flash loan for $70. You're depositing 100 total dollars, and then you are basically, you pay the flash loan back instantly during that transaction. And then on the second transaction for withdrawing, you're pulling out, you're pulling out your principal of $30. You're using a flash loan to pay back the $70, and then you pay that flash loan back again. So was it profitable? Yes, it was profitable. You can see the profit here. So you still supplied 30%. Yeah, you supplied 30%. That's what I was saying before. This particular strategy requires some money to make money, but you're able to amplify the flash loans with that. Okay, so let's actually look at the code and how it works. So let's look at our smart contract here. Let's see here. So can you make it wait by checking to see if earnings are greater than by X amount over the gas? Yes, you can do estimate gas and then calculate the earnings in there. Okay, so let's look at how it works. So basically, I'm going to pull up Compound's developer docs here. So these will be your friend when you're trying to develop with Compound Finance, and this is for any DeFi application if you want to know how they work. Looking through the thing. So the main thing is the comptroller. This is the main smart contract that's going to, use this is going to basically be the main contract that we use for compound finance. C tokens are how compound, tracks underlying tokens. Like, so it turns your deposit of DAI into C DAI. Okay. So those are the sort of nouns that you want to know. And when looking at this example, is a comptroller and the C tokens. All right. You can see here, we have the comptroller interface pulled in here. We have the DYDX flash loan pulled in here that we used in our previous example. All right. And we have the ERC20 token pulled into here for like our previous example. So here is our entire smart contract. Okay. There's a lot of stuff in here, but we're going to explain it. Basically, it's a leveraged yield farm. It comes from the DYDX flash loan. Okay. So basically, what we do is we track the DAI token on the Ethereum mainnet. All right, this is the actual DAI smart contract address. We create a copy of the DAI token in here. Then we look at the C DAI address, because again, whenever you deposit DAI into compound finance, it actually converts it to C DAI, which I was saying before. You can see the C DAI token information inside of here. Okay, we have the comptroller address. This is the main compound finance smart contract, like I was saying a second ago. Here's the comp token. This is the actual compound finance ERC20 token in the interface right here. Here's the DYDX flash loan smart contract address to do DYDX flash loans. Here's the smart contract owner. Okay, and so basically how this works is we have the constructor function that gets run once and only once. All right, we deploy the contract. And then it has some setup here that basically calls, comptroller enter markets, all right, with your C tokens. So this is something you have to do if you want to set it up to actually start interacting with the comptroller. So this is a really important example here. Excuse me, I'm about to sneeze. Mute myself. Okay. So let's look at the flash loan function, because this is going to be the main entry point for the entire application. All right. So you're going to do this for deposits and withdrawals. Again, to enter into the application, there's two steps. There's a deposit transaction and a withdrawal transaction. So for depositing, basically what you do is you paste in the DYDX solo margin address, which is the flash loan provider, the token address that you want to deposit. In this case, we're going to do DAI. The amount that you want to deposit, the amount that you have in your own wallet of DAI, the full amount that you want to go in to the contract. Okay. And then is deposit is going to be true or false. Now, this is going to say, like, if you're depositing into compound versus you're withdrawing, is deposit is true. It's false if you're withdrawing from compound again. So this will get market ID, gets it from compound finance. Like, what market are you going into? This is going to be for DAI. All right. Repay amount is going to be for doing the transfer. Okay. And so basically what you have to do is set this up for DYDX solo margin to do the operation. Okay. So this is just boilerplate code. You can see this like from the previous example here. All right. So basically what you want to do is actually look at deposit DAI function. And so the solo margin, you'll see how this sets up. So I actually misspoke earlier when I was saying that this is the main entry point for the application. These deposit DAI and withdraw DAI, these are two different functions. So I misspoke earlier. My apologies. I mean to correct myself. If you want to deposit, you can use this simple interface, which is deposit DAI. Withdraw DAI is what you call if you want to withdraw DAI. So it actually handles the, is deposit true or false. So basically, here's what we do. So just kind of reset the explanation here. So if you're going to deposit, you call this function. If you're going to withdraw, you call this function. So for depositing, you just say the initial amount. All right. So basically, let's say what it is, whatever your amount is, it does the calculation for you. So it does that 70% loan to value. So 30% is the initial amount, and then it uses 70% as the flash loan amount, does that calculation here. All right, then it calculates the amount that it wants to do for the flash loan by taking the total amount that we just calculated and subtracting the initial amount, which is what you're depositing. All right, and then we say, is the deposit true? And we call that flash loan function that I just explained, okay? So whenever the flash loan operates, it does handle deposit, okay? And so handle deposit does this. It approves the DAI from your smart contract, which it owns because you have to deposit DAI in the smart contract before you can do this. And then it mints the CDAI. That's how it provides collateral to Compound, is it does CDAI mint. It uses the C tokens. Whenever you mint CDAI, it basically takes the DAI tokens out of your wallet and gives you back CDAI. And it knows that if you have CDAI and you go redeem it from Compound later, it's going to pay you your interest back, okay? And then you borrow DAI by doing CDAI borrow the flash loan amount, okay? And then after, handle deposit is finished, okay, it does the it actually does the repayment of the flash loan, okay? So now the opposite is true on withdrawal. It calculates the initial amount. This is what you had in the application. It calculates the flash loan amount. Its deposit is false. It calls flash loan again, all right? And then whenever that's done, it does the handle withdrawal, okay, which is basically get your balance. It approves the DAI tokens. It repays the borrow to Compound. It gets the CDAI balance, and then it redeems the CDAI. Okay, and then we also have the steps of claiming the comp tokens. So you do comp controller claim, and you pass in the address, and it gets the comp tokens that you had for depositing. Okay, and then it withdraws the comp tokens back to your wallet. Okay, back to your wallet, back to this. Well, I say back to this smart contract, I should say, and then it transfers. To the owner. All right, back to the owner. Whoever owns the thing goes back, and then it withdraws the DAI back to the wallet as well. So you get your comp tokens out, and it gets your DAI tokens back out as well. And we also have this fallback function in case you get any money stuck into the application. You can just do withdrawal tokens, and you can paste in the token address, and then you can pull it out. Okay, but you can only do that if you're the owner, and it only sends it back to the owner's wallet. So that's your fallback function. So somebody says, I guess the deposit DAI, we need some DAI in the account associated with the Ganache account. So that's a great question. You do need some DAI, and you have to send it to the smart contract in order to pay the flash loan fees, and also to do the flat, just to have some money to do the deposit. So you always need to keep some DAI in the contract to do a flash loan. That is a caveat. So don't deposit all your DAI. You need at least a few way worth of DAI to perform the withdrawal. But we do all that inside your script. Okay. So if you're gonna do it in the real world, you got to send some DAI to the smart contract. But inside the script, we set it up for you. So basically, we just use the Uniswap interface, and we just swap some of the ETH from our Ganache account to Uniswap here. And basically we just say swap 1 ETH for DAI. We fund your account that way. We put it in the thing. And then inside of the tests, basically we do exactly what I was talking about. We basically we deposit DAI here. Okay. We transfer DAI to the smart contract after we swapped it. We deposit DAI. We call that function I was showing you before. We track all those variables. We track all your balance before. We wait for 10 seconds, all right? And then we withdraw from the thing. And then we withdraw the balances. We look at the balances after, and we put a summary on the table, okay? and you can see the wait function basically lets us wait for a certain number of seconds, and you can increase this to a longer time period to see how long your interest would accrue. All right, so that's pretty much an overview of that application. Again, if you want to change this, there's you can plug in different flash loan providers. You can plug in different applications and interfaces to come up with these recipes. But that's a fully fledged like DeFi application that you can just like turn on and it actually works. Again, there's significant risks associated with this actually doing this on a real blockchain. I try to explain those all very clearly in this presentation. But you can run these in a sandbox environment and practice them and get good at them with the exact techniques that I showed you without risking any money, right? You can plug this into different applications, different ecosystems, different DeFi apps, different chains, all that type of stuff. You can experiment, you can experiment small amounts of money on different low-cost chains. There's lots of ways that you can practice this and get good at it to create your own recipes, and it's an absolute superpower. So again, there's not much you can see in terms of the transactions, but this is what it would look like. These are what the transactions would look like on Etherscan if you were going to do it for real, okay? So basically, here's what it looked like. So basically, here's a deposit. All right, you borrow. This is like just $2.33, all right, from DAI, and you collected that amount of comp for borrowing. You repaid it, all right, and then there you go. So this is basically for $1, right? Like you deposit $1 and you borrow $2.33 on DYDX. You do the flash loan. Here's all the steps involved. All right, that's for the deposit, and then here's what it would look like when you pay it back. All right, so borrow from DYDX, supply, borrow, repay. Actually, sorry, this is the deposit function. So borrow this from DYDX, use $1 of your own money, borrow to pay back the loan, repay for DYDX. All right, then you wait. All right, and then when you pay back, this is when you claim the comp rewards. So you borrow the loan amount, you collect the comp rewards, you repay back to Compound, you collect compound rewards, you withdraw from Compound, repay back to DYDX. That's what it looks like step by step, start to finish, if you're going to verify an Etherscan. Okay. Let's see here. All right, so let's go ahead and move into a couple Q&A here. We'll do a few minutes of questions, and I'll go ahead and wrap up our presentation. I had some great questions in the chat. So how big of a flash loan is in that example? This is a small flash loan. So this was literally like a $1 example. So basically, this was like taking out. This is using $1 of DAI and then increasing that exposure with by taking out a $2.33 flash loan, and then using adding $1. Part of that's just easy numbers to illustrate the math how it's working. So in the complex transaction, do we have to pay gas for each step in the flash loan? Yes. So each step basically makes it heavier in gas. Don't we need to use flash bots? Definitely not in this case. I mean, you're using your own money in this cryptocurrency transaction, so there's no like directly extractable value. Can we have this on a loop to run for a month, for example? So you don't need to run it on a loop. The whole idea is like if you want to run for a month, you just deposit and then you wait and you come back and it works. What are the best cryptos to do flash loans for arbitrage? So there's no easy answer to that question. The opportunities change all the time. But the best way to do it is basically with looking at different tokens on top of other blockchains and support tokens. The sample transaction, yeah, we can share it. So when we borrow ETH, we have to provide ETH for gas. Yes, that is true. How do you get to run every 10 seconds? So that's a good question. It's not about running every 10 seconds. It's basically about this 10-second thing is to wait. So the whole idea is once you deposit, the money is like in the application, like it's on the blockchain. The 10-second waiting here is really just to say like, all right, we want to wait and see what happens whenever we withdraw and track what our rewards are. So somebody said, do I have an example due to arbitrage? Yes, that's a great question. So inside the masterclass, inside the video vault, we have all the past master classes. So if you're in the blockchain mastery program, you have access to all those. We have a complete trading bot solution for arbitrage with flash loans inside that trading bot master class. Go check that out. If you're not into the master class program, definitely reach out over email. We can get you switched over. Do we have an app to make all this easier? Yeah, the whole thing that I'm showing you right now, it basically is an entire app. There's no user interface necessarily, but the smart contract implementation is an app in and of itself. Can we take out withdrawal function and just call it later? Yeah, you don't have to do withdrawal function immediately. So the script that I'm showing you is to just test running in the mainnet. So if you can put it into a script to like run it on the actual thing, you wouldn't have to. You could just do the withdrawal later. So we're working on the compound testnet here. No, this is actually working with Ganache CLI that's actually forking the entire Ethereum mainnet. So it simulates what it's like to actually run this on the Ethereum mainnet. Can it compound your returns? That's a good question. So you would basically, you could code it to do that, where you could reinvest returns. All right, everybody, we'll give us a couple more minute warning for questions here, and then we'll go ahead and wrap up. It's been a great class, and I'm about to hit a recording limit for my broadcast here. So who do we reach out to for a bootcamp certificate? Definitely reach out to gregory@dappuniversity.com. We can issue your certificate of completion once you finish the bootcamp. Once we test it out and it shows to be profitable, would it always be profitable? So it will not always be profitable in the sense of at some point, compound liquidity mining rewards will stop, but that's not going to happen for a while. But theoretically, whenever those rewards finish, then they would cease to earn comp tokens. So that would be a limitation. Let's see here. Is it possible to loan big money, then deposit to earn yield for a long time? Yes. So to be clear, the motive is to maximize governance token rewards, not the interest itself. I'm assuming the interest on the principal that you deposit. Yes, that's correct. So come out answering questions for the setup. That's definitely what the blockchain mastery program is in there. We got a ton of great hands inside there. We got some awesome team in there helping answer those questions. So the Masterclass, Trading About Masterclass, yes, has a full, complete arbitrage example inside of there. So our website tracks all different crypto on different exchanges. I don't keep track of one. How do you invest automatically? You'd have to write the custom code for it. It's not a simple answer to explain, but basically you would just, once you withdraw, you would, you could withdraw your comp tokens and then keep adding your comp tokens back in there. How often can you run the app? Several times a day. It's not about running it multiple times. Once you've deposited, it's deposited. There's nothing else you have to do. Do we use only Mac to learn to code? Nope, you can use Windows. We have Windows setup instructions inside the blockchain mastery program. All right, everybody. I'm about to reach my recording limit here. This is a great class. Again, if you got any further questions, definitely jump inside the community chat inside our blockchain mastery program. We got a whole team inside of there. Awesome group of folks, helping everybody learn blockchain. We've got a ton of exciting people who are, jumping in, trying to get their hands dirty. We got a ton of experienced developers in there already. A bunch of people who are, aspiring experienced developers. We got a ton of great success stories out of there. I've personally hired people who have gone through those programs. You can check out any of those, stories on my YouTube homepage. It's really awesome community inside there. So if you ever want the most out of this, then I'd highly recommend taking full advantage of it. So you'll get a replay link tonight if you join the one-time class. Otherwise, check back. We'll have this inside the video vault. Thanks again, and until next time, thanks for watching Blockchain Mastery University.